Okay, so I think this is video number 6, if I'm not mistaken, no? So, we are now in the bracketing method. So, natapos na natin yung sa graphical. Now, again, I have said this one. Sa bracketing method, we need 2 initial guesses of the roots, dalawa. And these guesses must bracket or be in either side of the root. And if magawa mo tong dalawa na to, dyan na papasok yung different strategies to systematically reduce the width of the bracket and hence home in on the correct answer. Okay, so dito magde-differ aside from this one, these guesses, magde-differ din dito sina bisection method at false position method. Wait. Sa bracketing method kasi, dalawa yung itatakil natin bisection, pangalawa yung false position method. False position method. So, itong dalawa, they make use of these first two steps, no? 1 and then 2. Then, magdi-differ sila dito sa strategy, paano pumunta sa correct answer. Okay? So, dito lang sila mag-differ sa strategy. Okay. So, ano ba yung strategy na ginagamit ni bisection method? So, gumagamit daw siya ng incremental search methods. And it also make use of the generalization kanina that if may ma-observe ka na change in sign sa f of x on opposite sides of the root, in general, if f of x is real and continuous in the interval from xl to xu, and they have opposite signs, itong f of xl and f of xu, that is, when you multiply them, positive times negative, that is less than 0, then there is at least one real root between xl and xu. Okay. So, tulad ng kanina nga, if you have determined yung 2 initial guess mo, naka-bracket, no? 14, 15, then somewhere here yung root. Now, if yung f of 14 at saka f of 15, Okay, paano natin masasabi na bracket talaga ni 14 at saka 15 yung root? So, that is when we compute for f of 14 and f of 15, they will have opposite sign. Like, pwede yung isa positive and then pwede yung isa negative. Okay, or when we multiply, positive times negative, it's less than 0. So, yun yung criteria to make sure that nandoon talaga sa loob ng bracket yung root natin. Okay, so bisection method is also known as binary chopping, interval halving, or Bolzanus method. So is one type of incremental search method in which the interval is always divided in half. So ano nga ba yung incremental search method? So yan yung pag-locate kung saan, locating an interval, kung saan nag-change ng sign yung function. Then the location of the sign change is identified more precisely by dividing the interval into a number of subintervals. Each of these subintervals is searched to locate the sign change. The process is repeated and the root estimate refined by dividing subinterval into finer increments. Okay, so incremental search. So let's say meron kang interval dito kung saan change yung sign yung f of xl and f of xu. So i-divide mo siya into, or i-break down mo into sub-intervals. Then, mangyayari is you will search for every interval kung nasaan ba yung another change of sign. So, if malaman mo na nandito pala siya, between this one and this one, may change in the sign of the function. So, dito ka na mag-focus and then i-narrow down mo siya, i-narrow down until you home in on the root estimate. Okay, so yun yung incremental search method. Ito yung sinasabi dito na yung bisection method daw is one type of incremental search method. Pero yung way niya on lessening the interval, no? Kung paano niya to ginawa, pag mahanap niya na may sign of change dito, paano niya ba gagawin or paano niya papaliitin yung interval na to? Ang way niya is to always divide the interval into half. Okay, so i-average niya. So if a function changes sign over an interval, the function value at the midpoint is evaluated. The location of the root is then determined as lying at the midpoint of the sub-interval within which the sign change occurs. The process is repeated to obtain refined estimates. So yun yung concept ng bisection method. So ito yung mga steps in general using bisection method. Step 1 is to choose lower XL. Choose tayo ng XL and upper XU guesses for the root such that the function changes sign over the interval. Okay? And ma-check natin yan if the product of f of XL and f of XU is negative or less than 0. After doing step 1, step 2 is provide ka na ng estimate of the root which is determined by the average of XL and XU. Then step 3, you make the following evaluations to determine which sub-interval the root lies. Okay, so ito yung mga evaluations natin. So A, notice lahat ng ito, XL and XR lang, walang XU dyan. Baka magkamali kayo in your activities or exam. Okay. So, di ba nakuha mo na yung XR. So, i-multiply mo yung f of XL and f of XR. So, if less than 0 yung result or product, ibig sabihin nun, negative, no? Negative yan kasi less than 0. So, it means to say, magkaiba sila ng sign. Tama? And it means that the root lies in the lower sub-interval. Therefore, set XU equals to XR and return to step 2. So, anong ibig sabihin yan? Diba, meron ka dito. XL and XU. Kinuha mo yung, itong f of XL at saka f of XU, meron silang opposite sign. Now, kinuha natin yung XR. Then, we evaluate what is f of XR. Then, we compare, multiply f of XL and f of XR. Kung less than 0 siya, ibig sabihin, different sila ng sign. Pwede itong positive, pwede negative. So, ano nga ang ibig sabihin if there is a change in sign in the function? It means to say, somewhere within this range, nandoon yung hinahanap natin na root. So, bale, in your next iteration, this will be your XL. This will be your XU na. So, that's why nag-set tayo dito ng XU is equals to XR. Then, you repeat the process. Punta ka sa step 2, which is to compute na naman yung bagong XR mo. Then, you continue the process. Nakuha? Okay, so next. What if naman f of XL is multiplied by f of XR greater than 0 siya? So, ibig sabihin nun, they have, palitan ko to. They have, etong f of XL and f of XR mo, they have the same sign na. So, pwedeng positive, positive, or negative, negative. So, again, walang change in sign. So, hindi nandito yung interval natin, kundi nandito. No? I-project mo yan yung ito dito sa baba. Okay, so wala na siya dito. So, why search for the root there? In-approve mo na wala siya dyan. So, dito ka na lang tumingin. So, in your next iteration, this will be your XL and this will be your XU. Yes. Diba? So, that's why mag-set tayo. Isi-set natin yung XL natin into XR. Parang baliktad. I-set mo yung XR into XL. Okay? Di ba ito yung XL kanina? XU, XL, XR, XU. Na-prove natin na wala dito. So, bagong interval na lang, dito ka titingin. So, ito na ngayon yung XL mo, yung dating XR, then ito yung XU mo. Then, obtain ka ng bagong XR. Then, you make the following evaluations na naman. No? Sa same step, sa step 2. Balik ka ulit daw sa step 2. Now, if in any case na multiply mo yung XL and f of XR, ang sagot is 0, wala na kayong problema. It means to say that the XR is already the root. Nahanap mo na yung root. So, if that's the case, you can terminate the computation or stop na. Kasi nahanap mo na yung root. Now, in cases kung saan hindi for example, in exam, hindi possible na makuha mo talaga itong f of x L times f of x r equals to 0. Kasi baka mag-require siya ng mini iterations, let's say 37 iterations. So, kawawa ka naman kung i-perform mo yung calculations 37 times, no? So, gagamit tayo ng pre-specified tolerance, no? Yung ES natin. So, again, this is our pre-specified tolerance. So, if your pre-specified tolerance is 5%, so, calculate in every iteration, calculate the relative approximate error. So, if what you get is less than the pre-specified tolerance error, yung kaya mong ma-tolerate, no? You can actually stop na. You can actually stop na your computation. And then, yung pinaka-last na XR, yun yung ibibigay mo na rough estimate of the root. Okay, that's the rough estimate of the root. Ano yung relative approximate error? Di ba? Present minus previous ba yun? I-check nyo lang over present ba? Times 100. So, yung mga values dito, you are actually referring to your XR. Yung present XR minus previous XR over present XR. You multiply sa 100. Okay? So, in the next video, I will be giving you an example. I'll be giving you an example. So, i-stop ko muna